Hello guys, welcome back. So in this video, we'll be solving another question from network theory from GATE EC 2022 paper. So the question is as follows. A linear two-port network is shown in figure A. So I'll call this as figure A, B and C. So if you see, only the question will seem bigger, but trust me, solving this question took lesser time than writing the question itself. Okay, so let us go ahead. So linear two-port network is shown in figure A. So here there's a two-port network, and at the input they're connecting 10 volt, and output it's like a variable resistor. So that is also given. An ideal DC voltage source of 10 volt is connected across port 1. So this is port 1, and a variable resistor R is connected across port 2. So here there is a variable resistor. Now what they are doing, as R is varied, so they are varying R from some value to some other value, and they are measuring the voltage and current at port 2. So they are measuring V2 and I2, and it is shown in figure B as a V2 versus minus I2 plot. So here they have V2 versus minus I2. So what they are doing is, let's say they are setting R to 1 kilo ohm. Then they are noting what voltage it comes, what current it comes. They plot one point here. Then R they set to 2 kilo ohm. Again they get the new values of V2 I2 and plot the next point, and together they get a continuous curve. Okay. So then note that for V2 equal to 5 volt, I2 equal to 0 milliamp. So this is important. At V2 5 volt, I2 is 0 milliamp, and for V2 equal to 4 volt, I2 is minus 4 milliamp. So here always for the port 2 in a 2-port network, I2 is always going inwards. That's why they have taken it as minus I2, which means that minus I2 will be the current coming out of port 2. So when V2 is 4 volt, your I2 is minus I2 is 4 milliamp. So now they are saying when the variable resistance R at port 2 is replaced by the load shown in figure C. So now they are removing this R and replacing it with the 1 kilo ohm in series with the 10 volt combination, and they are connecting it to A and B. So this is A and B. And they are asking the current I2 is dash milliamp. So now they are asking the new current I2. Okay, so now if you see, it looks like such a big question, but it is based on a simple concept. So the only concept we are going to use here is we are going to simplify this network into a Thevenin equivalent. Okay, so if you simplify, what you will get? You will get a VTH and a RTH. So why is this simplification possible? It is possible because it is given as linear two-port network. So in non-linear case, you cannot take a Thevenin equivalent. Okay, so now you have R here, and this is variable, and I2 is in this direction, right? And what is your V2? V2 is your voltage across your variable R. So now what are the 2 points? Your I2 is 0 milliamp and your V2 is 5 volt. This is one point. And your second point is your I2 is minus 4 milliamp and your V2 is 4 volt in that case. So if you consider the first case, when can I2 be 0? Your I2 can be 0 when your R becomes infinite, right? In that case, what is your V2? Your V2 is nothing but your VTH. So from your first case, you got your VTH value, which is 5 volt. So this is equal to 5 volt. Okay. And from the second case, what can you get? Now you have two equations. So what is your minus I2? Your minus I2 is nothing but VTH by R plus RTH. So this is equal to 4 milliamp. This is one equation. Second equation is for V2. Your V2 is nothing but R by R plus RTH into VTH. And this is equal to 4 volt. This is your second equation. So your VTH is nothing but 5 volt, we already got, divided by R plus RTH equal to 4 volt. And from your first equation, what can you get? So 5 by R plus RTH is equal to 4 milliamp. So your R plus RTH is 5 by 4 milliamp. 5 volt by 4 milliamp. So if you substitute that here, you can get the R value. So R into 5 volt by 4 milliamp equal to 4 volt. 5 cancels. And if you take this 1 by 4 milliamp that side, you will get R as 4 by 4 milliamp. So your R is 1 kilo ohm. But you are not interested in R. Anyway, you are replacing it with this 1 kilo ohm with 10 volt. So you need to find RTH. So what can you do? You just substitute it here. So 1 kilo ohm plus RTH is equal to, this is nothing but 1.25 kilo ohm. So your RTH value is 0.25 kilo ohm. Okay. So this is your Thevenin equivalent. Now you are removing this R and replacing it with this thing. So let us do that. So you have 5 volt, 0.25 kilo ohm, and then you have 1 kilo ohm in series with 10 volt. Now you want to find I2. Remember that your I2 is in this direction, not the other way. So what is your I2? In this case, your I2 will be positive because on the right hand side you have a higher voltage than left hand side. So it is 10 minus 5 by your total resistance, right? 1.25k. So which is nothing but 5 by 1.25k. So this is 1 time, this is 0.25k times. So 1 by 0.25 is 4. So 4 milliamp. And your sign is positive. So your I2 is 4 milliamp. So this is what they are asking. And they're saying round off to one decimal place. So it's nothing but 4.0 milliamp. So that's all. It is very simple to solve.